All right, ladies and gentlemen, in this video we are going to discuss chords and the relationship between specific segments and relationships in circles. So the overall concept of this section is to be able to use segments of chords, tangents, and secants to find missing variables. Today, in this video specifically, we are going to be focusing on using segments of chords and the specific theorem that allows us to find some segment lengths. So let's take a look. The segments of chords theorem tells us that, of course, two chords are at some point in time, all right, if they're going in opposite directions, they're going to intersect. And what ends up happening is that they intersect in such a way that there's a relationship between the lengths of the segments. So if two chords intersect, what I always like to tell students that when two chords intersect, what ends up happening is that the relationship between the segments EA, EB, EC, ED, the relationship is that it's piece times piece equals piece times piece. And I know that's a lot, and if it helps, great. If it doesn't, I'm sorry. All right, but I've just seen in the past, just remembering that piece type of deal. When you're thinking about this specific diagram, piece times piece equals piece times piece. Let's take a look and see what I mean. Throw out an example here. What ends up happening? Well, two chords are intersecting, MN and times NL. So right now I have MN times NL equaling Kn times Nj. That's our segment chord theorem. Mn is x plus 2. Nl is x plus 1. Kn is x, and Nj is x plus 4. The goal is to find ML and JK. Well, let's go ahead and find the value of x. And don't be scared about here, guys. This is just some basic algebra. Let's do some FOIL. First, x squared, outer, x, inner, 2x, last, 2. On over here, we get x squared plus 4x. Let's combine some like terms. X squared plus 3x plus 2 equals x squared plus 4x. You notice that there's an x squared on both sides, so they will cancel on out. And if I subtract 3x, I end up seeing that x actually equals 2. So it looked a lot worse than it ended up being in the end, I hope. So the measure of ML, and so I'm going to erase this real quick so you can always pause the video if you need to. But if it'll erase for me, there we go. All right, so the value of x was 2. So ML equals x plus 2 plus x plus 1. So 2 plus 2 plus 2 plus 1. So of course we end up getting 7 for the value of ML. And for KJ, we end up getting 2 plus 2 plus 4 for a value of 8. All right. And that is the summation of our segments of chords theorem. Now, it doesn't matter what the scenario is, it's still piece times piece equals piece times piece.